All right, in this video, we're covering objective number 3 for section 4.1, which is being able to find the domain of a composite function. Okay, so let's scroll over to example 4 here. Here we have a function f of x that is rational, and g of x, it's a square root function. We want to find f of g of x as well as its domain. The composition itself is not too terribly challenging here. F of g of x would simply be 1 over the square root of x minus 3. All right, I'm just plugging g into f. And now I simplify. I'm going to rationalize by using a clever form of 1. And that's going to take me to the square root of x minus 3 over x minus 3. Okay, and there's my resulting composition. Now, to find the domain of this composition, you can't just focus on the result that I just circled. You have to first begin by finding the domain of the inner function, which in this case is g of x. Okay. So g of x, it's a square root function. You can't take the square root of a negative number, right? So that means this expression that's underneath the radical has to be greater than or equal to 0, which means x has to be greater than or equal to 3. Okay, so understand what this means in terms of the composition f of g of x. So these values of x that are greater than or equal to 3, these are the only numbers that when you plug them into g will give you a result to then be able to plug into f. Okay, any number that is not greater than or equal to 3 will not give you a result for you to be able to then plug in as an x value in f. Okay, so at the very least, the domain of f of g of x has to be any number greater than or equal to 3. Okay, but now you have to take this set of numbers and just make sure that there aren't any other values within it that make the overall composition not have a result. So there is one particular value here that I need to exclude, and that's the number 3 itself. Because if you think about it, if I were to plug in 3 right here for x, it would zero out the denominator, right? Which means you wouldn't have a result for the overall composition. So that means the domain needs to change for the overall composition to be any number just greater than 3. Okay, let's write that an explanation for that out. So when you're looking back at this, you understand where we came from. All right, so we have to say you must exclude 3 from the overall domain because it would zero out the denominator of f of g of x. Okay. All right, let's move to one more example. In this example, both f and g are rational functions. We want to find compositions in both directions as well as the domains of each, okay? So I'm actually going to begin by just looking at the domain of each of these individually. For f, the domain is any number except -2. And for g, the domain is any number except 1, okay? Now let's do f of g of x first. Okay, so that would be 1 over 4 over x minus 1 added with 2. Okay, and this is a complex fraction, a fraction within a fraction. That's clearly not simplified, so I'm going to kind of clean this up by multiplying by the denominator of that inner fraction on the top and the bottom of the overall larger fraction, okay? Now, I see a lot of algebraic mistakes made here. Understand this is going to simplify to x minus 1 over 4. Think of this x minus 1 as being in parentheses as one whole piece. It's got to multiply the 2 as well as 4 over x minus 1. So when I multiply it by 4 over x minus 1, that just leaves me with 4. And then when I multiply it by 2, I have to distribute there, and it'll give me plus 2x minus 2. And then I clean up. I end up with x minus 1 over 2x plus 2. Okay. All right, so we can leave it like that, or I guess you could put it in a factored form. Doesn't really matter here. I'll factor 2 out from the bottom. Okay, so domain for this is going to be based off of the domain for the inner function, which in this case is g. Okay, so g could not use an x value of 1, so that means the domain here has to exclude 1 as well. But then, are there any other numbers for x that would not give you a result for the overall function f of g of x? And the answer would be negative 1 as well. Okay, that's because negative 1, when plugged into the denominator of our result, would zero out. Okay. All right, now let's go in the other direction, and you're going to see it's not going to, be the same, exact result, and the domain's not going to be the same. G of f of x would be 4 over 1 over x plus 2 subtracted by 1. I'll kind of take the same approach to simplifying this. I'll multiply by the denominator of the inner fraction as a clever form of 1. Treat that as one whole piece. It's going to have to distribute, and it's going to lead me to 4x plus 8 over 1 minus x minus 2. So that's 4x plus 8 over negative x minus 1. And then I'm going to factor just like I did in the first half. So pull a 4 out. And there we go. All right, so domain for this one is going to have to include the domain for the inner function f. So that means x can't equal negative 2. But then x can also not equal negative 1 as well. And that's because negative 1 would zero out the denominator right here in this result. Okay, so again, comparing the two domains, notice they're not the same for each one of these compositions. Okay.